Hi, everyone. Welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Batum with Atlanta Functional Programming. My apologies for the late start today. Unfortunately, various interruptions prevented me from actually starting the stream at the appropriate time of 1 o'clock. Hopefully, we have no interruptions as we continue on today's discussion. In today's episode, I thought we'd complete, or at least attempt to complete, the project that we kind of set up ourselves on a few weeks ago, mainly the issue of updating cl-neo4j's library to allow the ability to incorporate or embed Cypher queries into our common Lisp functions for the purpose of maybe allowing a Lispier API for generating transactions, as well as even in some cases being able to write out particular Cypher queries in a way that didn't require you to explicitly write a string into your code that doesn't follow the particular Cypher semantics to almost in many cases provide a form of usability inside your Common Lisp applications for your APIs. The discussion today is going to be um, mainly focused on just trying to get the information in so that we can actually start discussing or at least trying to pull out the essence of the implementation of the cipher to string macro that I was discussing a few weeks ago into our program. Last time when we talked about this, I kind of proposed three different strategies, if you will. Um, the first one, of course, being potentially maybe writing something like this, where we had kind of S expressions in a Lisp-like language, um, and passing the Lisp version of the Cypher queries into the Cypher query function or Cypher query macro, and it generating this expected output. Um, that turned out to be a bust mainly because of the fact that it was discovered, or at least realized, when we were trying to implement this using the Cypher query statements that we saw here, that the open paren ended up having two responsibilities. One from the standpoint of Common Lisp, in that it indicated the start of an S expression and or a list if it was a quoted open paren. Otherwise, it would have, in the case of Cypher, it would have indicated a node because the node has indicated here in the match expression here represented something that had some sort of metadata, maybe a label associated with it. And in some cases, it may end up having something like this, where we had a piece of metadata, a label associated with it, and some associated data within or properties using the Neo4j lingo associated with that particular node. So that ended up becoming somewhat of a failed experiment. The second case that we started thinking of is maybe creating kind of something like this, where we had a Cypher query that took it as is. And that kind of brought in some discussion of what match and so forth would have represented, but it ended up converting and being able to generate the same thing. But this also encountered the same issue that we had with case one, in that parentheses is now talking about what is it? Are you talking about a Lisp expression, or are you talking about a Cypher node? What is it that the open parentheses indicated when we were starting to lex or tokenize the actual stream inside of the macro? So what ultimately we ended up discovering was that we would have to end up writing a reader macro and modified the Lisp reader, which was case 3, which allowed us to provide some sort of potential um, uh, what have you, a potential start to a reader macro, and it actually allowed us to write native cipher inside of that reader macro, and then we had a terminator macro. And this is something that we ended up starting to start covering the week before. Particularly, we talked about the different types of macros that are available. We had a nice review of that, and we ended up trying to implement our own compiler macro as an example. But then we ended up implementing our own reader macro here to implement a list comprehension. And we ended with trying to start talking about what kind of infrastructure we would end up having to end up doing and the concept of the read table inside of Common Lisp. As a quick review of the read table, when you actually open up your Common Lisp REPL, you can actually look at the read table by looking at the dynamic variable read table. And this actually has a bunch of different readers associated with the actual read table, indicated by the actual character table, hash table that's provided here. And this ends up having a series of dispatches that you can end up leveraging to actually go to the appropriate read function that we are associating with that particular reading of that character in the stream. This read table can be modified by the set macro character available to you as part of the standard Common Lisp API. However, as we saw last time, there are some constraints and or caveats that you need to be aware of when you are modifying the read table. In particular, there are some overrides for particular characters available in the read table, uh, provided that the overrides that you are providing it doesn't necessarily trample with what Lisp is kind of expecting when it is trying to parse those particular characters. And what I mean by that is in our case, when we were talking about the uh, open parentheses and closed parentheses, which were necessary to indicate nodes inside CYPHER, we needed to make sure that outside of reading a particular function, uh, the global read table should be untouched. And when within a function, we should be able to go and change that. And that's where we were um, ending up with before. So I started doing some of the infrastructure work from last week to this week, specifically with regards to the um, read read table setup. And in particular, I started implementing essentially overrides for each of the individual like characters that I needed to handle as special cases. Okay, some of them ended up being pass-throughs in order to get some of this working, and I thought I would at least show some of my initial results with you and share with you what I found today. The first thing is obviously the read functions for some specific characters. So here I should really label this as left read lparen. I had a reader for um, the read semicolon as well as read space, and finally our final read cipher query here, which will end up calling out to the stream and then call this override delimited list. This here ended up working out, provided that we actually ended up directly modifying the read table. I'm going to actually re-implement this for you today, slightly differently based on what I found out over the course of last time we covered this material. So we have these individual readers for tokenization, but we haven't yet actually set up the read table. Okay. Now to do this, we have to first actually, as you recall from last time, we need to first copy the old read table into a new read table. Okay. Before I do that, one thing I'm going to actually mention, and this is very, very important to realize, and that is since we are modifying a dynamic variable, the read table, with certain overrides and that are special implementations of functions in the case of what the Lisp reader is expecting it, or in other words, instead of, when we are dealing with actually um, modifying the behavior of the core Lisp reader, it is good practice to actually go ahead and not just do like a copy table globally inside of your package and then locally do some stuff. Unless there is a specific reason that you need multiple cases for this, it would be better to actually define this inside of a function. So we're going to go ahead and create this new version of read cipher query, where we do cipher query and then we do stream and character. And what we're going to do is for now, since we're not actually going to look at character, we're going to just go ahead and ignore that. Now this indication setup here is mainly so that we can actually register this in a read table later on if we ever wanted to. Right now, I'm not going to actually deal with that. Um, the actual main beef of this implementation is revolving around modifying the current read table. Okay, and that is, let's go ahead and create a closure where we have a copy of the read table using copy read table. Now, one thing to note, and I'm not sure if folks can actually read this on my in my mini buffer. So I'm gonna go ahead and pause here for a second and go into the buffer here to kind of show you what this is doing. Copy read table actually is a pretty straightforward function that was provided to us as part of the standard API, and it goes and copies from a read table and returns the actual result. Now, it if you end up providing, it takes two arguments. One is both are optional. The from read table defaults to the global read table, and the target, the to read table, doesn't need to necessarily be specified. If it is, a new read table is actually created and then returned. Otherwise, the target read table is used, and the from read table is copied to the to read table, and the to read table is returned. Um, the read table itself and this is specific to the Common Lisp implementation. The from read table defaults to the standard read table, which we are seeing is in any Common Lisp implementation, it's going to be specified by the dynamic variable read table surrounded by earmuffs, or as I call it, earmuff read table. Um, and that's actually already defaulted set up into the actual um, copy read function. It's actually a default argument to from read table if you don't specify anything. So that's what we're actually doing here right now, and that is we're actually using that no argument thing to allow it to copy the current read table as it is today. Once we have that, we can actually begin overriding the read table. All right. Um, One thing to note is when you are overriding, it would be generally good practice for you to override it with an unwind protect so that you don't forget to actually set up um, the call to copy read table, and you copy from copy read table to um, read table to make sure that everything is properly cleaned up. We're going to go ahead and set up a prog n so we can actually go in and set up individual calls to our code. And the first thing we're going to end up doing is calling out to set macro character to set up um, our actual what's it the characters that we're actually overriding. Now I've actually done this already slightly. So I'm going to go ahead and skip ahead to a couple of things, which is we're going to go and do just 1 second. I have this in a buffer. Scratch. Okay, and let's go ahead and copy these. Okay, so we're gonna go ahead and do this, and let's go ahead and set this up. This is using a different library that I'm gonna show later on what this is about. But for the time being, I didn't think that this would be um, useful. So we're gonna go ahead and do this the old way of doing things, which is calling this up to a set. There we go, and then set macro character. So what we're doing here is we're setting the macro character and providing overrides to open paren, semicolon, space, open bracket, and then close bracket. Now, this here is actually not really necessary since we're actually setting this up to do read cipher query right now to not deal with having its own reader macro. We could just go ahead and do this and get rid of that, and we're actually good to go. Given that we've actually set this up, we can actually now go and hold on. Yeah, we can actually now go in and set up the actual call to read. And the read is going to be just go ahead and do a read delimited list and tell what's it, the close parentheses. Oh, actually, we're going to probably have to provide a set macro character um, to being, let's say, read l brac and set macro character to read get macro character to close, and then we can actually do this on the stream. Okay, and let's just quickly in defun read lbrac do this. If they see an lbrac, we're going to choose to ignore, and we're not going to actually do anything. Okay. Oh, let's do this. We're just going to ignore what's in it, and we're just going to call it. Now, the reason we're doing that is because we're actually eating the lbrac to get started on the actual reading of the cipher query. Okay. Um, so in this case, the open brace represents the start of a query, and the closing brace is going to be representing the ending of a query. And what we're doing is we're just going to go ahead and spit out the tokens that it actually gets. And when we exit, we're going to actually use the global read table. Okay, so this is what we're going to actually do. And what we're going to do is we're going to first say read cipher query from standard from read line. Okay, so oops. Okay, so it's undefined. Let me first define it. Sorry. There we go. And let's change it. Now, let's do that. Good. Then let's do create a basic thing. This is just generating it. So what this is actually going to supposed to return to us is a proper um, uh, string. And it looks like I forgot. Oh, right. I think I messed up. Oh, right. Okay. That's what I need to do. Oh, dummy. One more thing I forgot to do, which is, it's not this, nil. And so since we're trying to actually get from input, we need to provide a string. Well, for us, luckily, there is a function that allows us to create a string stream from a string. So we could do read line, which will give us a string. str will generate a string stream for us. I mean, with input from string, we'll take that read line and generate a string stream for us, and then we can actually use the reader to actually go and parse that string. So let's try this again. Create a person. Okay. And we could see that we actually generate, it gets a nil. You could see that it gets a create, a hashtag space, and then you could literally see each character being spit out individually for this particular um, uh, function call. Okay, and so this is a good first step, right, to what we were kind of expecting. And we could see that there were spaces in between each of these individual things, and but this isn't completely done yet, right? Because obviously what we want to be able to do is just spit this out individually. So let's go ahead and do that. And that is, we can use a do list. We will, sorry, we will get the item for each thing that comes into the list, and we're just going to go ahead and throw this item into an outer stream. Okay, so what we'll do here is create a with output to string out, and this will spit out what's in the string, and then obviously we will return the out before exiting the function. Okay, so let's read that again. Undefined variable out. Wait. Oh, right. I'm using this in the wrong context. There we go. Now we have everything good. Okay, so now let's try this. And we do create a person. And we can see that this is actually getting a little closer to what we're kind of now expecting, right? Um, Obviously, here, there's still a couple of things in that. As you can see here, the nil is being passed in to the character for whatever reason. So let's see if we could fix that. Let me see if I could do this. Okay, that's nil. Let's see if nil. Okay, so let me actually do this. Maybe it's because of the L bracket being returning nothing. Let's do that. Okay. Sorry, let's do this and let's return this stream. Let's see what happens here. Okay, so the problem was that. So what we need to do is ignore character and just not write out. Let's do that. Let's see if I can do that. No, hold on. Okay, so this space is actually going to be uh, returned, but we need to eat the actual character that's being provided when it opens up the read L bracket. And that can easily be fixed by, um, okay, so that's a space. Hold on. So let's do this. Okay, so this actually will work. Let me do this. Create a person. And we can see that we're getting much closer to what we're kind of expecting. Um, the one thing now remaining, of course, is prink for some reason. So for folks who doesn't know what prink is, prink takes it stands for print character. It takes whatever object, Lisp object that you're providing, and it actually spits it out into the output stream. So to kind of show you what prink does, let's go ahead and quickly go to the documentation. Output an aesthetic but not necessarily readable representation of an object onto the stream. Okay, so what we have to do is you have two problems. One is for each of the individual items that we're getting, we're while we're outputting the stream into the stream, what we're kind of expecting. What ends up happening is it's introducing an additional space in between every individual character. We don't actually want that individual space. So let's see what we could do to actually get that individual space out, shall we? Let's try format instead and see if we could do this. Sorry, that we don't even lowercase. We don't even need to actually specify that, and see if that actually will concatenate the strings the way we kind of expect it to. Okay, so now let's do this. Create a person. Okay, still actually creating, and there's still individual spaces between each of the characters. So something is preventing us from actually providing. Let me see. I do. What happens here? Okay, so we see a character, individual. Each of these is getting. They are individual characters, so I don't understand why it isn't treating them as a single string. One way of handling this is obviously to only treat this as a single string at the top, concatenate them as a single string at the top when we're actually reading it from the open paren. So right now what we're doing is we're collecting the items themselves. And while that's all well and good, obviously that's not what we actually want. We want to be able to, we actually want the actual string to being together. So let's try actually doing this instead. So we will change this back to print because it really should be that. And instead, what we'll do is in lparen, until we get this, instead of doing collect, what we'll do is with output to string out, create a string here, and do format out, format out tilde a item. This should create a proper string for us for each character that's being provided. Then what we'll do is after that's collected, we'll go ahead and just return that and see if that causes any issues. Undefined variable. I have an item here. Oh, right. There we go. I somehow accidentally stole. Oops. That's when I was the problem. Okay. There we go. There we go. All right. Let's see if that is changed. We do this. A person. Ooh. Okay. It's getting slightly better. Oh, wait. I forgot to do that. Forgot to overload. There we go. Oh shoot! It's still doing what I didn't want it to do. Looks like. Let me do this. Print out. Let me see what happens before I split into it. Hold on. Format T. It is spitting out what I didn't expect it to spit out. Let's see here. So it's not actually allowing me to spit this guy out the way I expect it to. Let us do this. Let me see if I could put a breakpoint right here. So I can actually go and look at the reader. Create a person. Okay, I see. It is actually not actually, it's not actually reading. Ah, that's the reason. Okay, so we have a break. go up here, get rid of this. There you go. So this is getting closer and closer to what we're kind of expecting. And the only thing that is now missing is read paren is actually not doing grabbing what we were expecting it to do. So let us okay, it's doing it without the parentheses. If we have, hold on, I want to pull out the original concept here. Um, no. Okay, so I'm going to do this and print this guy out so I could actually have a copy of the old version. Oops. Nope. There we go. Now, let's rewrite this again. My apologies. I'm just going to quickly spit out what we did earlier a little blindly. Do okay. There we go. Did output string out. Okay. Then we go in and here do format out tilde a item out. Okay, and then we got this. This is incorrect. So let's do um, to we're going to go ahead and do this first, which is print, not print, prink out, sorry, prink item out to spit out the open character. And then when it hits the end, we're going to also prink this to out to close the node. So the problem here is we're eating the nodes. So we don't want that. So we're going to grab the character for the first one and we're going to close it. Okay. So now this should actually do what we're expecting it to, but we need to first go here, oops, here, and change this guy to l-paren again. MCF, good, MCF, read, create a person, and we now have our first working implementation of a cipher to string character. Okay, so let's review what we just did. The first thing we did is we created individual tokenization functions, mainly focusing on the node, which is L bracket, sorry, not L bracket, l-paren, okay, read l-paren for left parentheses. And what we did is we created an output stream, specifically an output string stream, and we wrote out the beginning character because we need to still indicate inside of Cypher that we're starting a node. Okay. In Common Lisp, when you read the open parentheses, what ends up happening is that parentheses is eaten and you tend to ignore it until later on. We've seen that somehow in some cases that we didn't actually ignore it. We chose to actually, when we collected the items, it was still part of the actual stream. But we actually did not end up leveraging those items. It was actually, the format didn't actually go in and um, print that start of the node. So we ended up having to write that out ourselves. Okay. So luckily, when we call into read l-paren, the stream is passed in the character that it was eaten. So we are able to correct that by calling out prink and being able to print a character for both um, uh, the open paren and close paren. Then what we did is this is string concatenation right now. What we're doing here, we're reading through the entire stream till we hit the end of thing, and we're getting everything out here. What this allows us to do is the following. We could actually do this, although I'm just going to let you know this will end up adding some spaces later on, but this shouldn't be that big of a deal. But this, we could say, hold on, actually, let's call this the matrix movie, and let's say name the matrix. Oh shoot, I forgot. The Lisp reader will not be able to deal with commas right now because comma actually in do Emacs means we're gonna call out a command. So hold on, I may have messed this up. Let's do this again. Do this. Okay. Create the matrix movie, name the matrix. Okay. And you can see that we actually ended up creating a proper the matrix setup. This does not handle properties yet. We will actually have to deal with that. Specifically, we have to adjust this to deal with properties, but I want to hold off on that to show you the difference between what we just did and what we provided earlier. So this is actually, this actually can work. This will end up can be leveraged actually by your code pretty directly. Couple of things that obviously makes this a little bit um, restrictive. Okay, this is a nice single function that can actually end up being used to actually stream your syntax and do whatever you want. But what if you just want to be able to take the read table as is and move it around from one place to another? Okay. Obviously, this piece of code, the unwind protect, the copy read table, can all be good, but you want to be able to take this as a single object, especially for folks who are coming in from an object-oriented world, and be able to actually instantiate this reader table every time you got to go read it without actually having to call reader cipher query directly. You just want the read table. You don't want to necessarily do the read delimited list, for example. You might want to parse it a different way, or you want to call the reader into some construction or what have you. Okay. This alone will not fix your problem. You need to essentially have namespacing for readers. That's what named read tables would end up giving you. We kind of briefly talked about named read tables when we were talking about read macros last week. But I thought I'd show you the justification of why this is. So now take this guy here, and let's go ahead and change, and let's use the named read tables implementation and see how that might change things slightly. So first, I will go back to my buffer, my scratch buffer, because it has my named read table syntax. I'm going to go ahead and grab this, and I'm just going to print this guy here. Hold on, let me do this. Shift G. Here we go. Better. Okay. So, and here has a review for name read tables for folks who haven't weren't here when we talked about this. Name read tables provides you with a name spacing functionality to go and define read tables and then just refer to them when you are wanting to use them in particular cases in a scoped namespace fashion. Okay. What it does behind the scenes is def read table and in read table are actually macros that actually check to see if we have a hash table of these read tables already provided for us. And if so, it will go ahead and construct a new read table that merges in this case, we're using standard read table. There's actually a couple of others like modern, which does case sensitivity, and I think Common Lisp is the other one, which is basically equivalent to standard with all the read tables as defined by chapter 22 of the Common Lisp the language book. Or I think the read table specification is also available for your viewing on the hyperspec. Either way, that merging will end up essentially taking our overrides and then providing whatever isn't overridden from the standard read table. And once this is set up, you can then have this other macro in read table that will go and essentially create this closure that we've created that it takes in the default read table, does a copy, and then does an unwind protect to actually go and set this stuff up. You can actually see this if you actually do a macro expand, where it essentially sets up the read table here, and then locally it will then, within the scope of a particular function, it will actually go in and keep this read table as is until it exits the scope of the function or exits the scope of the region that you're evaluating, and then returns it to the standard read table. Okay. What's nice about this is let me go ahead and do that. We overridden it. Is I can now do this, and in my code in a file, do an mcr, and the hell? Oh, I forgot. My read cipher query no longer actually does this. It does, let me do this. I have to define this slightly different. Let me do this. oops, I just do this. We're going to have to define our read cipher query syntax because, as you can see here, we're actually naming the read cipher query syntax here as being part of the reader. And we're just going to go ahead and print out this information. Okay. Okay. Let's do this. And let's clear the REPL so we can actually see what it does. And if we go and do that, oh, right, I have to go and rename this so we can actually get this information. And now if we do that, we end up getting our reader the way we expect it to. All right, notice that everything is correctly defined. We're actually getting what we're expecting here. Obviously, a couple of things that we'd probably want to do is we had in our original talk of, sorry, our uh, original definition of, there we go, of the ontology that we defined inside of Neo4j, we had the matrix all properly case sensitive, and it will actually appropriately do what it's supposed to be, which is it'll keep case sensitivity in the reader, and we'll preserve it here as you can see here. Okay. So this is all great. We now have set up a single conversion to actually do what we kind of wanted to do, which is take a single query and generate kind of the full query that we could then pass over to with transaction. I'm gonna submit this code for into my reader, my fork of the cl-neo4j library, which I will post in the YouTube description. But my hope is for folks who are watching this, the lesson that can come out of this is a pretty straightforward thing. Mainly, to write a reader, it's actually, and extending the Lisp reader, it's actually a pretty straightforward exercise. Number one, it's a matter of you essentially writing overrides for the particular characters that you're tokenizing that you want to override in the basic Lisp reader and use whatever is available to you that isn't. And then the parser becomes essentially you extending once the tokenization is done, uh, figure out how to dispatch when you're actually finding particular pieces of syntax to actually to generate your particular language or to execute your particular language. It's really not that difficult. To extend the Lisp reader and override the Lisp reader is pretty simple. There are some caveats, mainly you have to be careful when you are trying to mix between Lisp mode that has certain semantics that needs to be preserved and respected, and non-Lisp mode where you're actually trying to put your overrides in, as we saw in the last couple of weeks. But if you're able to respect that, it's a pretty straightforward thing, and hopefully this can convince you that the the extension and writing out of this syntax will become a pretty straightforward thing for our Lisp wrapper. So I'm going to say that this is the end of what I'm going to be covering in terms of the graph databases overview and the overview of CYPHER, as well as what I thought would be we could get out of the CYPHER project. Um, Please leave a comment inside of the chat if you'd like to see more and maybe updates to this library, as I'm going to extend it, for my own personal needs, and maybe hopefully it's generalized for folks to actually find useful. If you have any additional comments, questions, concerns, um, anything at all, just please, feel free to ping me um, on the chat. You could post your comments in the YouTube chat. Sorry, under the YouTube video, and then if you like what you see, please hit the subscribe button. Um, so you can see new videos coming, hopefully more every week, as the Common Lisp Study Group runs every week. A final announcement: as always, Atlanta Functional Programming is looking for speakers for those of you who are in the Atlanta area. And if not, if you're willing to give a talk online, feel free to ping me. I am Bugram on the Functional Programming Slack channel. I also squat in the Lisp Discord server periodically. So if folks, ping me on there, I will certainly see your suggestions and or comments, and I will, act accordingly. Uh, Next week, I'm hoping to see you guys. We'll have some new topics to discuss, and but I don't want to uh, ruin the surprise. I'm hoping to find something a little bit more definitive during the week and then ping you guys about it. Um, but as usual, thanks for all you joining, and I will see you guys next week.